Hey everybody, welcome back to Jim's Garage. So hopefully by now you've either spun up your K3S or RKE2 cluster. But I've been a bit neglectful, so sorry. I've given you all the shiny toys, but I haven't told you how to use them. So whilst you can have a look through my scripts that deploy some of the manifest files and do some of the Helm installations, I think it's time that we went through an actual Helm deployment in slow motion. And equally, we need to create manifest files so that you can move some of your existing Docker applications over to Kubernetes. So that's what we're going to do in this video. I'm going to take our WireGuard setup that we had in Docker Compose, and I'm going to show you how to convert that into a manifest file so you can deploy it within Kubernetes. That means you're going to be able to see how you actually do it for all applications. I'll talk about things like what are services, what are ingressors, what are deployment files, what are PVCs, all that good stuff. And then you'll have the bonus of having remote access to your cluster. After that, I'm going to pick a Helm installation and show you why you might want to do Helm, where sort of Helm applies in terms of the home lab versus enterprise space, and some of the commands associated with upgrading them, etc. So let's jump straight into it. I'm going to have the Docker Compose up on one side of my screen, and then we're going to create a manifest file from that. And I'll talk you through all of the bits within the manifest file and what it all means. The first thing to note before we do that is, don't worry if this all looks scary. I was in your position, but it's actually not that bad. Both of these, the Docker Compose file and the deployment files, they're all YAML files. They just have a few more lines of code in a manifest file, and there's a few more indents, etc. So whilst it does look scary, it looks a lot bigger, etc. There's nothing in there really that once we've been through this video should confuse you. Okay, so we're on to my respective virtual machines for this. And off the bat, I'm going to apologize if this isn't as edited and as slick as it usually is. Haha. That's because I want to try and do this in real time. So you know that there's no sort of trickery going on, and I want to try and do this to show you that it is pretty straightforward once you understand some of the basic concepts. So here on the left, I've opened up my WireGuard-Easy Docker Compose file that we went through on my previous video where we spun this up in Docker. So if we look at this, just to remind ourselves again, we had the WireGuard-Easy container where we specified some environment variables. So in this instance, I haven't tweaked it too much because I just set it up for the demonstration. But the main thing here is that we look at the environment, and you can see those environment variables here. Now, I'm not going to focus too much on what all of these are for now, i.e. the values, just that we need to specify some environment variables. Next, as always, we need to specify an image that we're going to pull down. We can optionally give it a container name, but it's really useful to do so. We specify a volume because we want some persistence on this container, because all of the keys we create for our users, we want to retain them so that when we reboot the server, the same users still have access to this server. Next, because we're doing some port forwarding and it needs to be exposed to the internet, we need some ports specified. So you can see those here. Remember, the UDP is actually for WireGuard, and the TCP is actually for the WG-Easy GUI interface. On top of that, we've got the capability add. Within Docker, this WireGuard needs to have some administrative privileges around the networking and the system module. And on top of that, we need to set that the IPv4 forwarding is true, and that all services are valid is true as well. Don't worry too much about those, you can go and check out my previous video. But all I wanted to get to is, we've got a YAML file here, the same as these over here, and we'll come on to those in a moment. But it basically just specifies how we want WireGuard set up to deploy. So, this is taken from my Docker machine, all of this stuff here. So let's go into my admin machine for my RKE2 here. Apologies if that's small. I've tried to make this font bigger in light of some of the comments that I get for people watching this on mobile. So what do we have here? Well, we have a default headers. Now that's for routing this through the reverse proxy. So think of that as a bit like Traefik labels, which are missing on here, but you probably have that WireGuard-Easy routed through Traefik using those Traefik labels. The next one is the deployment file for Kubernetes. And the Kubernetes deployment is basically all of sort of this stuff here. It's where you specify the image, it's where you specify the names, the volumes, the ports, etc. We then have the ingress, and the ingress is again building on the default headers, but it's more specifically around things like the URL we're going to use. And last is the ingress route UDP, so that's just another ingress route. However, this one's for TCP, and you guessed it, this one's for UDP. Now, all of these are basically bits of this separated up. You can go into each of these YAML files, and I could combine them all because you can use delimiters to separate the files out. I like to split them because if I need to make a change to the ingress, I can just go to the ingress file. But if you wanted to, you could put them all inside the deployment, and you could call these files anything you wanted. They don't have to be named like I've named them. So let's jump into this and see what they all mean. So the default headers, if we open this up, this is instructing Traefik. You can see here, Traefik. This is creating a middleware, which you'll have seen again from my Traefik videos where we create middlewares. Now, typically, we've done that statically with things like CrowdSec, where we've done it in the Traefik.YAML, config.YAML, etc. And that's pretty much what this is, just with a different name. And as you can see, it's setting some variables within the headers specification of Traefik for this service. Now, I'm not going to go into too much details here. You can read up what all of this stuff does. But it's doing things like forwarding the header to HTTPS and doing things like turning off cross-site scripting, etc. All that kind of stuff. You don't technically need all of this stuff. This is just to bolster security of the tunnel that you're going to access it with. So hopefully you can see that this is very similar to Traefik labels. The next bit is the bit that you're probably most interested in. So this is the deployment. So I'm going to try and put this alongside the Docker Compose on the other side. So let's walk through it. So all deployments want some metadata. So metadata is just a fancy way of labeling this container. So you can see that we've set labels, handily called labels. We've set that the app is called WG-Easy. We've set that the instance is WG-Easy. Its Kubernetes IO name is WG-Easy. Its name is actually WG-Easy. Now, I don't actually need all of these. It's because I was playing a bit. But just know that you can basically create any of these in any format you want as long as they're consistent. You could also put in your own custom labels, a little bit like we did with Longhorn equals true, and you could put them in here. Now, what that means is when you apply rules later on, you can just reference these things. So you could say, apply this Traefik rule, and I'm not meaning Traefik the reverse proxy, I'm talking about things like network security policies, etc. And you would tie them to something like, apply this rule where name equals WG-Easy. So that's why you have labels. Hopefully that's clear. If it's not, I'll try and explain it later on with an example. So the next bit is the specification. And this is the bit that's going to look a little bit more like a Docker Compose file. Now, this whole structure of this file, you can basically copy and paste. And this isn't something clever that I've created. This is just taken from some of the examples on the Kubernetes website. So this will look pretty much the same for any deployment, whether it's within your home lab or within enterprise. This is just what manifest files look like. Now, there are a ton more of the specifications that you could put in here, and I'm arguably missing one that the more seasoned Kubernetes folk would be saying, hey Jim, where's your CPU and memory allocations? Because that is really important at enterprise scale. And I should add them, and I will add them. And the reason you would add them is because if you specify how much CPU and RAM this thing needs, it can be better allocated across the nodes, i.e. if it needs a certain amount of CPU and only one of those nodes has got that amount of CPU, it will try and schedule it on that one. The problem with home labbing is a lot of these applications that we're running aren't necessarily that mature or don't have sort of off the bat support for Kubernetes through manifest files. So a lot of this has been me trying to retrofit Docker Compose into Kubernetes. Now, anything that runs in Docker should run in Kubernetes, so you don't have that problem. But anyway, I've gone a bit off track, so let's get back onto it. So within the spec, you're going to set the replicas. Now, this literally means how many WireGuards do I want to run? And you might be thinking, well, you've made me spin up 8 virtual machines. Could I have 8 replicas? Well, remember, we've set ourselves to having 2 worker nodes. So we only want our containers to run on those 2 worker nodes, and typically those 2 worker nodes will have more resources, i.e. a greater amount of CPU and RAM to accommodate the additional workload. All of the rest we've kind of kept to either being a master node, so very specific in what it does, or Longhorn storage, again, very specific in what it does. And we don't want to try and conflate all of that, because the more complexity we add onto those dedicated nodes, there's the more chance of things going wrong. So, okay, we've got 2 worker nodes. Why don't we have 2 replicas? Well, we don't need to load balance, and typically load balancing is one of the reasons why you would have more than 1 replica. So for somebody like, I've used this analogy before, but like Netflix, they'll probably have thousands of replicas because they'll have millions of customers all trying to access things at the same time. And that load balancing is really critical because people are watching stuff in real time and they can't afford any performance interruptions. I'm just me accessing WireGuard on my own, and 1 instance of WireGuard is going to be fine. Now, remember, Kubernetes is also self-healing. So that means it's not just 1, and if it fails, uh-oh, never mind. Because we've got the master nodes in high availability and they can all talk to the workers, this is effectively what it's trying to achieve. So it's always trying to have 1 available. So if my node goes down that it's running on, and I've got 2 workers, the master nodes will say, hey, we're supposed to have 1, we don't have 1 available. Right, we need to go and put this on the worker that's available. So as long as you've got 1, Kubernetes will always try to have 1, i.e. you're always going to have it and you've got failover. So you don't actually need 2. And 2 can become very complicated, or more than 1 essentially, especially when you have things like databases, because you don't want multiple applications all trying to write to the same database. You need something that's designed specifically to be multi-tenanted, high availability databases, and that's a really complex conversation. So hopefully that understands why we've got replicas, and you'll notice that I actually set my Traefik to have 2. That was more just an example, but because it doesn't have any persistence, that doesn't matter with the storage comment I just made before. It's just going to be running in memory, and there's nothing being written to disk. Everything's actually stored in things called a config map, which lives within the master nodes. More on that later. After that, we see the first example of what I was talking about earlier. We assign labels up here, and then we select them down here. So we're saying all of this specification for this container applies where this condition is true, i.e. this label is matched. And we know it's going to be matched because we call the deployment up here WG-Easy. Bingo. Next, we get onto the template. And so if we look here, we can see that we've got the labels again to make sure that this works, i.e. it's going to match what we specified earlier. And we've got the node selector of worker equals true. So we know that we've got 2 worker nodes, and in this deployment, it's going to instruct the master nodes to try and assign this deployment, this pod, onto a node where worker equals true. So we don't care which one, Kubernetes doesn't care, as long as it's got 2, as long as it's got 1 available that it can assign, this should start to deploy. Now if we scroll down further, we'll see that we've got this security context here. And this security context is actually down here at the bottom. You can see it here. Now, I've left this in just to demonstrate an example of where I've copied it across, but actually it's safe to delete this. So I'll delete this when I upload it to GitHub. And that's just because Kubernetes doesn't need this to operate. These are Docker specific commands and it's not necessary in Kubernetes. Next, we get onto the containers section. So within containers, we have environments, and those sound pretty familiar. Let's remind ourselves of our Docker Compose file here. Yep, environment. So if we look at some of these environments, you'll notice that they look pretty similar. That's because they're just in a different format. So in Kubernetes deployments, you need to have a name and a value rather than a dash, the variable name, and what it equals. So for example, we've got WireGuard host. You can see that over here. So WireGuard host equals, in this instance, the name is WireGuard host and the value equals. Pretty simple. Again, we've then got the password, and this is going to be the password for accessing the GUI. We've got the default DNS. So in this instance, I've set that to be what my DNS resolver is within the internal DNS within Kubernetes, and then its DNS name as well. After that, again, it's pretty straightforward. We specify an image. Now, this image is exactly this image here. The image pool policy is always, so that means whenever I reboot this container, delete this pod, whatever, shut down a node, every time it pulls WireGuard-Easy, it's going to re-download that image. So that's a good way to get an update each time, but also be mindful that sometimes you don't always want to pull the latest version. I know a lot of people love the Watchtower Docker container, and it is great for getting the latest of certain images. But also, if there was a breaking change and it wasn't caught, and believe me, that does happen, my whole network went down because I had Pi-hole set to latest and it broke all of my DNS. It's always DNS. So just be mindful of what you want to set this to. You don't have to set it to always. You can find the options that you can change it to in the Kubernetes documentation. Next, we're going to give this pod a name, so WireGuard-Easy. And then we're going to specify some ports. And again, these ports look exactly the same as these ports. So 51820, 51821, those are exactly the same. Now, you'll also notice that we gave it some capability adds over here on the Docker. So we had netadmin and sys module. You'll notice that we've got security context, capabilities add, and we've got the two again here. It's just in a different format. And again, like I said, you can just replicate this as a template. This isn't something that I've created. This is part of the official documentation and what a deployment looks like. The next bit is the volume mounts. Now, as I mentioned, we wanted persistence. Now, that's a little bit simpler in Docker, especially if you use either a volume or a bind mount, because you would just have something like this over here, and that would be mapped to the host or some SMB share or whatever it might be. In Kubernetes, it's obviously a little bit more complicated just because you don't have the notion of fixed storage, especially if you're using something like Longhorn, where that is highly available and replicated over multiple nodes. But again, it's quite straightforward. So in this instance, we're doing a volume mount, and I'm saying that I want to mount etc WireGuard. So this is going to mount some data into the container at that location. Now, to do that, we want to make what's called a persistent volume claim. Now, this isn't in Docker. This notion doesn't exist. So what this is saying is this is where it's going to mount the data within the container, a bit like this bit here. So this is going to say anything in home Ubuntu Docker WireGuard goes into etc WireGuard in the container. So you're going to have all your passwords stored in this folder, so things like your keys for accessing your WireGuard, and then if you exec into the container, that's going to show up exactly in this folder here. So that's the same notion here. But the difference is, in order to achieve that, it's not going to map it to the host because we've got Longhorn to do that for us. Longhorn is on a different virtual machine, and that virtual machine could be on a different physical machine. We don't really care. So to do that, we create a persistent volume claim. So this is saying persistent, we want a persistent volume, and we need to make a claim, i.e. we want one. We're instructing Kubernetes to create one for us. And in our instance, Longhorn is set up to listen to that and then go, fine, you want some storage, I'll give you some storage. Now, we can actually go and create that in code, and you would do that with you see this delimiter here, you would have another one of these for a persistent volume claim. But unfortunately, that creates one with a random name. And I don't like that because it looks a bit ugly in Longhorn and it's not always obvious what is what. So I like to create this persistent claim, and I'm going to call it WG-Easy. But when we spin this container up, you'll see that the container hangs. But all we need to do, and it will be just like the Pi-hole one, we're going to go into the Longhorn GUI and we're just going to create this, and then it will automatically get assigned. So don't worry if you see something broken. It's not broken, it's in a pending state. And those are all the little bits that you need to spin up this container. It's really straightforward, it's simple, and it's quite a minimal image. Others will have way more environment variables, etc. But you simply need to go through this bit here and flesh it out exactly the same as you would with your Docker Compose. That's it. Now, I mentioned before that I like to split all of my files out. But I've created an example here where I've got multiple within the same one. Now, I've done that because if you see this, and you might see examples of manifest files out there for certain projects, just know that anything between these three dashes could effectively be a separate file. So I could call this service.yaml if I wanted, and then it would be another file within my folder. Or you can just combine everything into a single one and just use these between the files. Anyway, let's get back onto what this is. So this is a service, and this service has the same labels, and the specification is it's selecting the app WG-Easy. So again, this service is only going to apply to WireGuard. But let's go back up to the top. So what is a service? Well, the service is what begins to expose the container. So you're setting up a service to be able to access this, and you can probably guess that from what the ports mean. So within a service, you specify some ports. So I've given it a name, UDP, 51820 UDP, and you'll see that over here on the Docker Compose file. That's exactly what that is. Now, this is the port and the protocol that WireGuard uses for its traffic. We've said that it's 51820. This is the container for the port, i.e. what it expects. But much like in a Docker Compose file, you can change whatever's on the host and it will redirect it to this port here internally. That's the same concept within Kubernetes because you've got the target port here. So you could specify this to be whatever you want, and it will always reach 51820 inside the pod, i.e. the WireGuard container. Now, apologies for the quick edit, but I think it's important to add some more detail here. So as you can see, we've got a type of a cluster for the IP. So what this means is it's going to give it a static IP within the cluster. Now this would be a bit like in Docker, where it has its own internal network IPs. And it will make sure that that's static and we can access it across the whole cluster. So any node could access this via that IP. Now, this is different to how we have Pi-hole set up in the previous example I had. So if we look at Pi-hole, which we can see here, Pi-hole, we see we've still got the same spec, ports, name, etc. But down here, you'll notice that we've got an app, Pi-hole, and an external traffic policy for cluster, and a load balancer IP, and in this instance, the type is load balancer. Now, you can also have a node IP, I'll come on to that in a minute. But the key difference here with the load balancer IP, and this is important because it's the bit that throws up most of my users, the load balancer IP is the bit that kubevip is listening to. So when it gets a request from a service for a load balancer IP, it's going to pick an IP that's available outside of that LBIP range within my script. So this is just going to make it externally available to your network. So anything, so something like the device that I'm recording this video on, will be able to access it on a static IP. And that will be load balanced throughout the cluster, and if the container has to move between nodes, it will still pick up that same IP address. Now, that's really important for something like Pi-hole, because Pi-hole on port 53 is going to be doing your DNS requests. So all of your devices, so your Linux, your Windows machines, your mobile phones, whatever, they need a static IP to be set for the DNS resolver. So that's why we have a load balancer IP here. We can get away in this instance with a cluster IP in my WireGuard because I'm actually running WireGuard through Traefik. Now, if you don't want to do that, and it's probably a little bit complicated to get started with, you could go back to this method here and you could give this WireGuard a load balancer IP. And then it would behave probably exactly the same as any Docker application, where if you're running WireGuard-Easy on your Docker host, odds are you're specifying the Docker IP for your internal port forward. You would do exactly the same thing here. You'd put it as a load balancer, it would be assigned an IP, and you do your port forward to that IP. Now, I also mentioned you could have a NodeIP, and the NodeIP is pretty similar to how you have your Docker host. So in this instance, if you set a NodeIP, if we went into Rancher, we know that each node has an IP, and these are the IPs that you set in my installation script. So that would be very similar to how we do Docker, where you would specify the node IP, i.e. this is the node that WireGuard is deployed on. So in our case, it's one of the workers which have static IPs. It would be that IP and then 51.820. You get the idea. So you decide what you want to do. WireGuard probably makes sense if you're starting off to have a load balancer IP, but if you want to have it routed through your proxy, you want it to a cluster IP, and then you'll need to make some entry points on your Traefik, and you'll want to route it through there. Next, I've got another service, and you'll see that this is a copy and paste of the one before. However, this is for the web GUI of WG-Easy, and it's exactly the same, except we've bumped it up to 21. We've changed the protocol to be TCP because it's web, and the target port is that. But again, I could change this port to be whatever if you've got a port conflict, and it will always route it to 51.821 internally. So that's the deployment, and you could run this and it should deploy and spin up, but you wouldn't be able to access it yet through your reverse proxy. Now, I should note that you don't have to have things going through a reverse proxy. I've just put my WireGuard through my reverse proxy as a bit of an academic exercise, but you don't have to do that. So if we look at the ingresses now, so these are basically telling Kubernetes to punch a hole to that service, but it's actually telling Traefik to do that. So my WireGuard is coming externally from the internet, hitting my firewall sending that to Traefik, and then Traefik is sending that to the WireGuard pod. So this will look almost identical to the Pi-hole ingress, which we use to access the dashboard. So again, we have a namespace for it. I put all of these within the WG-Easy namespace, so this is to group all applications in their own respective namespace, a bit like you would have kind of micro-segmentation, everything in its own little area. And again, this has got a name, and then we do a specification here for web secure. So that means that this ingress route, i.e. Traefik coming in, it applies to web secure, which by default is port 443. So this is to expose the GUI. So if I go to WG-Easy, jimsgarage.co.uk, port 443, it's going to send it to port 51821, which we know from the deployment is the port that's assigned to the web GUI. And if we don't want to use www. You just want to use the subdomain, we can also do that. And I've got the middlewares here of the default headers, which we saw earlier, which if you remember is just a configuration for how we want that Traefik tunnel to be set up. And the crucial bit, which you probably saw within Pi-hole before, is that we want to specify my secret, which is my TLS certificate, so that we can access WG-Easy through Traefik, and it will be secured with HTTPS, SSL, we'll get the green tick in the address bar, etc. So that's that. That's pretty much all you need to get this spun up. So let's hop into the terminal and let's deploy this, and we'll check it out deploying in real time with Rancher. Actually, just before I do that, I'm going to go into my ingress and I'm going to change this to be WG-Easy 2, just because I'm currently using that on my internal DNS. So I'm going to hit save, and we should be able to access it on this when we deploy it. So logging into Rancher now, we can see that we've got my node. Let me just zoom in. And in here, we've got the 8 nodes, which you should all have now. So I've got my Longhorn, I've got my 3 master nodes, and then I've got my 2 worker nodes. So if we hop into the terminal on our admin machine, or any machine that has access to the cluster, i.e. it's got the kubeconfig file, and I'm going to be using kubectl to do this, we should be able to deploy it. So I've gone to WinSCP, I'm already in this machine, I'm going to click on putty, and I'm going to log in. So here we are on the machine. Let me just blow that up for you. And now we're on the machine. We should be able to deploy this. So we need to do a kubectl apply -f. And if you look over here, I put it in manifests WG-Easy. Now the cool thing is you can do folders for deployment. So you don't have to specify these each individually. So to do that, we do manifest, hit tab, and then I'm going to do WG-Easy. And I should be able to hit return on this, and it should go and deploy all 4 of those files. Now, it complained that I didn't have the namespace, and that's right. I could actually create the namespace in one of these files, but I didn't. So if we do kubectl create namespace, and what's it asking for? WG-Easy. So now that's created, and then hopefully we run the previous command again. There we go, great. Created, 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 created. Excellent. So now if we go back into Rancher, we can see that it created the replica, it created the replica set, it created the deployment, but it's failed to schedule. Now, why is that? Well, the clue is there, persistent volume claim. We haven't given it any space, and we've said that it needs a persistent volume claim. So how are we going to fix that? Well, we're going to click on Longhorn. We're going to go into Longhorn. We're going to go to our volumes, and you'll see the Pi-hole one that we've already got up and running. Let's create a volume. So we're going to call this one WG-Easy because that's the namespace it expects. I'm only going to give it 1 gig. I'll have 3 replicas, so this data is triplicated for redundancy and backup. Then I'm going to hit OK, so you can see that that's been created here and it's detached. Now I'm going to assign this by hovering over there and going to the create PVC at the bottom. Sorry, create PV PVC. It's already pre-populated the name, that's fine, and then I'm going to put it in the namespace of WG-Easy, WG-Easy. Now when I hit OK, after a few seconds this should change from detached. Now, yeah, it has, attaching, perfect. So that means if we go back into this tab and we go back onto the cluster, it's now attached. So that error has gone away. Successful attach, and now it's pulling the image. So this is exactly the same as a sudo docker compose up-d. It's going away and doing it. Now remember, we also set up GitOps, so you could just drop those manifest files into your GitOps and it's going to go and pull it and do it all for you. But that doesn't help with what we're trying to do on this video, which is you want to create those files first. So now it's pulled that image. Fantastic. So if we head over now to our workloads and we go to our deployments, which it was on default, you can see here that it's active and there's 1 running because we set the replica to 1. So let's click on WG-Easy, and there you can see our pods. Remember, the pod is where it runs and we can delete pods. So here you see this is up and running. It's been running for 2 minutes. So click that and then we can view the logs, and this is exactly like looking in Portainer or doing an exec. So what have we got here? It's listening on 000, great. On 1821, on 821. It did the generate key, that's hidden it because it wants to keep it private for itself. Yeah, it's turned the interface on, everything's synced. So with any luck, I'm now going to go into my Pi-hole. I'm going to create a DNS entry for WireGuard-Easy2.jimsgarage.co.uk, and then with any luck, I should be able to access this. So I'm going to head to my Pi-hole. When I've logged in, I'm going to go to local DNS. So I'll copy this one. I'll pop that one in there. And the IP address is the IP address of my Traefik load balancer IP. I'll add that. I'm going to open a new incognito browser just to avoid any caching and paste and go. Bingo! We got there, and look, it's got a certificate, and if you followed my Traefik script, you should also have this working. So there you go. That's how you deploy a manifest file. It's as simple as that. So let's get on to its counterpart, which is the Helm chart. So a Helm chart is probably the enterprise way of doing this. As you can imagine, it's a bit ugly doing all of these different files and doing it this way. You want something that's packaged. Now, I actually use a mix of Helm deployments and manifest deployments. And you'll have seen in my Traefik script that we actually used a Helm installation for Traefik, and we also used a Helm installation for Cert Manager. So what's the difference here? Well, let me show you with an example. So why don't we deploy something like our good old friend Portainer? Now, more to come on Portainer, because I'm actually going to show you in a future video how you can manage dual environments from within Portainer. That's right. You could, instead of using Rancher, you could use Portainer to manage your existing cluster and also your existing Docker. So the same instance of Portainer for two completely different environments. That's really powerful. More on that later. But we're talking about Helm. So handily, Portainer offers a Helm deployment. So that's what we're going to do today. So the first thing we're going to do is create that namespace. So we're just going to run this command just like we did for WireGuard. And then just like in previous videos, and if you looked at what the script was doing, i.e. the printout of when you ran that script, we added a repo for a Portainer to Helm, and then we did an update to apply that. That's basically the same as what you do when you install something on Linux. You might have to add a repository, and then you have to update your list from that repository before you can install it. It's exactly the same principle. Next, we're going to install the chart. And it's really straightforward. You either need to do an upgrade if you've already got it there. I think you can actually do an upgrade off the bat. But usually you would have to do a Helm install and then a Helm upgrade. But I think the first time you can do it is an upgrade. I think that's fine. And what's that going to do? Well, it's going to install Portainer. But, well, what about environment variables and all that kind of stuff? Well, that's really straightforward. And you do that, if we scroll down, you'll see all those parameters are here. We do that with a Values.YAML. Now, if we go back to our existing setup, so if you go back to your Helm, where my script pulled all this stuff down for you, if we look at Traefik, for example, you'll see there's a Values.YAML file with Traefik. Now, all this is doing is basically setting all of those Docker Compose variables within one file called a Values.YAML. So in my Traefik one, for example, you can see things like don't send anonymous usage, have two replicas. We just saw that exact thing where we set one for WireGuard. It's got a worker selection, so true for the node. It's got the ports, so the web and the web secure, and those are port 80 and port 443. It's got the providers for certain things. It's got the actual service itself, which we set up as a separate file. Well, it was actually within the deployment file. But exactly here, it's the same sort of stuff. We're saying that we want it to be a type load balancer and give it an IP address. And within the Helm manifest, within that and within that Helm, within the values, you specify all of the same stuff. So with each Helm deployment, there will be documentation on what you can set. Now, there'll also be a default, and the way that Helm works is, if you do not specify something here, it will use whatever the default is. And you'll be able to find typically the default values.yaml on their GitHub page. So whenever you specify something, and we'll get onto that in a minute, it will overwrite what's in the default. So let's get to work on that. I'm going to create a new folder on my admin machine in the Helm. Remember, you can just store this how you want. I like to do it like this. I'll create a new file directory, and I'm going to call it Portainer. And within Portainer, I'm going to create a new Values.YAML. So Values.YAML. And so that's now created. So for example, let's have a look through the configuration. What might we want to change? I know, node selector. We probably want to specify this, right? Because I want Portainer to only be on my worker nodes and nothing else in my cluster. So if I didn't select this, it would just deploy it anywhere on my cluster. So we know that this value is going to work because hopefully this should only be on either 4 or 5. So I simply need to go to here, and this is already called values.yaml, and by default that's what the Helm chart will look for. Paste that in here, and then we need to get the right format for this to work. So a bit like with the deployments and what I said for Pi-hole, once you've got this right for once, you can basically copy and paste the format. So if we go to my Traefik values.yaml, where I already had that set, what does this look like? Well, it just looks like that. Node selector, worker true. So I could just literally copy and paste this into this new one we're doing here, and then that's in the right format. Now remember, this isn't something I've created. This is the default format for doing these things. So we hit save, and now when we run the Helm chart here using these commands, it's only going to assign Portainer to these nodes. Fantastic. Now, this is all you need to get it up and running, i.e. you only need to run this command here, the Helm install or Helm upgrade, and it will go away and do that. But to access this, you're going to need that ingress. Now, the service will already be part of this, the Helm chart, or it usually is. Let's go down because we can probably see where it's going to specify the port. Here we go, yeah. So service type, service port. So we probably want to set some of this stuff as well. So we want to set the service type, the service port, node port, all that kind of stuff. And this is exactly what we've just seen in the Traefik example. So again, we just need to change this. So I'm going to go back to my Traefik because I've already got this set up, and I'm just going to copy and paste that in and amend it. So like I said, you can find all of this documentation just on the website, on the GitHub, or in the Kubernetes, or in the Helm documentation, but it all follows the same format. So let's have a look. So service.type, so service, and then .type, well, we want this to be a load balancer. Before that, we want it to be enabled true, obviously. We're going to leave the annotations blank. You can put some in here again. That's the labeling again. I'm going to leave the labels as blank because it should work without them. Now for the spec, in this case, I don't need to give this a load balancer IP. That's because I'm going to run this through my Traefik proxy. So I want to be able to access Portainer through Traefik, so it's going to give me that SSL certificate. So I'm just going to remove that. The load balancer source ranges, that can be fine, just left, and the external IPs, again, just leave that. We could probably even delete all that stuff. So remember, if we delete it, it's just going to use the defaults. So I'm going to go ahead and hit save. Now, on top of that, we probably would want to go and put some persistence in here, and so you can see that down here. So we would have a section here, persistence, we would type that in. Next, we'd have enabled equals true. We'd create another line called existing claim, or we'd have another one which is create a claim. Then we'd specify the names and the size and all that stuff. We'd jump into Longhorn and do that. I'm not going to do that in this video just because I'm spinning up Portainer just to access the UI and get this up and running. So now that we specified some Helm chart values, let's go and deploy Portainer now, and then we're going to add an ingress, and with any luck we should be able to access this through the Traefik proxy and have SSL and connect to our environment. So the first thing we need to do is we need to go to the top. We need to create this namespace. So click that, and then it's exactly the same command as before. Let me just clear this to make it easier. we're going to paste that in. So kubectl create namespace Portainer. That's created. Perfect. Now we're going to add the repository. So we want to put this in. Helm repo add and then Portainer GitHub IO KTS. That's fine. Ignore those. It's just because I've got the wrong kube fit. It's just because I've got the wrong kube config permissions. I can fix that. Next, we want to do the update. So now we've added the repository. We want to do the update. So Helm then goes and looks at that repository, and then that will enable us to do the Helm install. So great. That's gone and pulled it. And you'll notice that I've also got some others in there. You'll also notice CrowdSec. I'm going to show you how to do CrowdSec in a later video. So now that we've installed the Helm, we've updated the repo, we can deploy this. But in order to use the YAML file we've just created, the Values.YAML, we need to do a -f and specify it. A bit like we do with a kubectl, where we apply a specific deployment or folder. So we want to go to the deploy here. So we want to get this command here. And we want to paste that in. So this is going to do a Helm upgrade or install interactive, so we see what it's doing. In the namespace of Portainer, which we created, and it's going to be called Portainer, and it's going to pull it from the Portainer/Portainer repository. So at the end of this, let's just make sure we're there. We're going to do a -f, and then remember where we are. We're just in the home directory. So I'm going to just make sure that it knows where we are. So I'm going to do a ~/, and then I'm going to do a Helm, yeah, and then I'm going to do a Portainer, and then I'm going to do a Values.YAML. So now when it deploys this Helm installation, it's going to refer to this specific YAML file which we just created. So with any luck, we run this and we'll get the setup of Portainer exactly like we specified. So that's now going through the deployment, and you can see that it's up and running, and it says happy helming, which is always a good sign to see. It's deployed it, and you can see I screwed this up a couple of times doing this demo because it's revision 7, so every time you try and deploy this, it will create a new one. And at the end, it says we should be able to access this. So let's hop back into Rancher now, and with any luck, we should see this on our cluster page. If we scroll down, we can see that Portainer, the pod, has started being created. Jackpot, that looks great. So let's go into workloads and let's see. Here's Portainer. It doesn't have the minimum availability. Now that doesn't necessarily mean there's an error. If we click on that, it could be pulling the container. So yeah, this is likely downloading Portainer. And because my internet's terrible, that's going to take a little while. So hopefully in a few minutes time, I should have downloaded this and this should change to green, much like we had before. So yeah, that's good. It just did it in real time. And you can see it's been given an IP, if I move my ugly mug out of the way, that it's got 10.42.417. Perfect. And it's on RKE 205. Now that isn't load balanced at the moment, and we haven't created an ingress to access this, but it should still be there. If we click on the services tab, yeah, you can see it's here. So it's actually running on the node. So I have some confidence. I can click on this, and if I change this to be HTTPS, I should be able to access it. Yeah, excellent. So that's now running, and it's running by itself just like it normally would on Docker if you don't run it through a reverse proxy. If, however, I now went back, and effectively, if we go back to the manifest file and the WireGuard or the Portainer, it doesn't really matter. If I basically copied this ingress file into the same Helm folder, or doesn't really matter where you want to put it, and I changed the namespace to just be Portainer, because that's the one we created. And I changed the host here to be portainer.jimsgarage or whatever. And I changed that port to be, I think it's 9443. Keep the secret name the same. And then I do a kubectl apply this ingress, I should then be able to access it normally. So let me prove that to you. I know the proof's in the pudding. So I'm going to copy that. I'm now going to go back into my Helm folder, Portainer, and I'll do a new file. I'm just going to call this ingress.yaml. Again, doesn't really matter, but it makes sense to call it what it is. I'm going to paste that in here, and I'm going to make the necessary changes. I won't do that in real time because it's a bit boring. So now that's complete. I've got the ingress route, names Portainer, namespace Portainer, Portainer 2. I'm just calling it that just because I'm already running Portainer. And you'll notice that it's calling a middleware default headers. Now that doesn't exist, so we've also got to create that. So I'm going to save this, and now you'll see here I've got the ingress and the Values.YAML. So what we need to do is create a default headers. Now again, I'm not just cheating here by copying and pasting. Again, these templates are all the same, so it doesn't really matter. So I'm just going to copy and paste this into my Helm chart for Portainer. So right click, I'm going to create a new one, and it's just going to be called default headers .yaml. And then I'm going to paste it, and I'm going to change again the namespace just to be Portainer. And I think that's the only change we're going to need to make in this one. Yeah, that's fine. So I think because the service file is already part of the Helm deployment, that's how we were able to access it through this bit here. I should now be able to kubectl, apply those two files. I don't want to do the folder because it's probably going to complain about the values.yaml. It doesn't know what the hell that is. That's because it's a Helm file, not kubectl manifest file. But if I apply these two files, and remember I need to go into my Pi-hole, and I need to now create a Portainer 2. So portainer2.jimsgarage.co.uk. And then if I point that to my proxy, 192.168.3.65, so that's now in there. And then we're going to hop back into our terminal. Let me just clear that. And then we'll do a kubectl apply -f, and remember this is in Helm /Portainer, and we first want the ingress, so we'll deploy that. That's created, and then we also want the default headers, so that's created. So now if we go back into Rancher and we go to more resources, we go to Traefik, and then you can see here that we've got an ingress route for Portainer that was created 33 seconds ago. So that's good. And we should also have a middleware of default headers. Yeah, that's here. So with any luck, I should now be able to go to Portainer 2 and reach this. Well, we reached it, but there's a slight error. So we've got the valid cert, and I think this is because I need to change the ingress. So I think I need to specify that it's HTTPS. So let me just do that now. Yes, so because this is running on HTTPS, I need to specify that as well as passing the host headers. So I need to do that in the services, and that will look like this. So the scheme is HTTPS because remember, even though it's using a self-signed certificate, we're pointing this to 9443, which is the HTTPS port. I could change this to 9000 and I don't need this, but some things don't run without a self-signed certificate, i.e. it needs encryption whether it's valid or not, and we need to pass the host header. So hopefully if I save this, head back into my terminal, and then I reapply the ingress, this should just go through and say, yeah, it's configured. It would say unchanged if it hadn't changed it, so it's reconfigured it. So with any luck, I should be able to refresh this page and hopefully get there without any errors. Yes, we did it. So now we've got Portainer using a valid SSL cert through our reverse proxy using a Helm deployment. So hopefully that's been really useful for you and you understand a little bit more about now how to create manifest files and what Helm deployments are. Now, I've just scratched the surface, but it's enough to get you up and running in a home lab. But please do go and read the respective documentation for both of these methods. So, thanks for watching, everybody. This is something I probably should have done a bit earlier, but at least now you've got both the tools in place, i.e. you've got K3S or you've got RKE2. And now you know a little bit more about how to transfer your Docker Compose files into manifest or Helm Chart deployments. Now, you choose what you want to do. Helm charts are probably easier, but not all applications are going to have Helm charts. And even if they do, some of those might be community driven, which is great and awesome, but sometimes those aren't maintained, so you might run into problems, and sometimes they may even be pinned to older versions that you just cannot upgrade to. And that introduces both security issues and perhaps it's going to be missing features that you might want or may not even be compatible with certain other things on your network. So at least now you know how to do both Helm and manifest, and hopefully you can just replicate your Docker Compose files into manifest files. This was a lot of fun to go through, but hopefully now you've got all of the tools you need to make your home lab in Kubernetes awesome. So if you like this video, please give it a thumbs up, consider subscribing, and I'll see you on the next one. Take care, everybody.